Hey guys, today I'm gonna show you how to solve the derivative of arcsine, arccosine, and arctangent. Okay, let's start with our arcsine. Okay, so dy dx of arcsine of x. Okay, so let's start. Right, this is unknown. Okay, so yeah, I'm gonna say that y is the arcsine of x. Okay, if I want to have the x alone, what I should do is this. Okay, I'm gonna say that the sine of y is x. Okay, I apply sine to the both sides. Okay, now what should we do here? First of all, we need to understand what is this. What is this expression trying to tell us? That's the first thing that you have to ask yourself. Okay, so let's do it. Okay, perfect. Yeah, so here I'm gonna have the y, right? This is an angle. And what it's trying to say here is that the sine of y is x. Imagine that here you have a 1, right? This is the hypotenuse. So you have the opposite side, right, over the hypotenuse. So this is x and this is 1. If I want the adjacent, the expression is this one, right? 1 minus x squared. Perfect. Okay, now we should derive this expression. I mean, this expression, we need to obtain the derivative here. So we say the following. The derivative of sine of y is cosine of y, right? dy dx equals to 1, right? Remember, in case you don't know, you have this expression, and what you want is a derivative. It's a derivative, okay? Perfect. So this is implicit differentiation, this one. Okay, now that we have this, we should have only dy dx. dy dx is equals to 1 over cosine of y. And oh, surprise! What is cosine of y? Cosine of y is this one, right? And at the end, we're gonna have 1 minus x squared. And this is how you solve it. So, just so you know, the derivative over dx of arc sine of x is this expression, okay? This case, you don't have to memorize the derivative, okay? Now, let's go with the other one. Let me have it over here. Yeah, it's good. Let's go with the arccosine, okay? Sorry, just give me 1 second. Let's start doing what we did before, right? At the end, we're gonna have that y is arccosine of x. Okay. If I apply sine to both sides, we're gonna have cosine. Cosine of y is x, right? I'm applying just here cosine and cosine. Now, what this expression trying to tell us, and sorry, I'm gonna have this figure, okay, but I don't want to start drawing again. Okay, so yeah, let me Erase this one and this one. Okay. So at the end, what it's telling us is that the cosine is the adjacent over the hypotenuse. So the hypotenuse is 1, right? And here we have x. Okay. So in case I want sine, or in case I want to have this side over here, I should do, right? What should I do? I will have to say this is 1 minus x squared. Perfect. Now, once that we have this, we need to derive, right? We need to derive this one and this one. So I'm gonna have is, cosine is minus sine of y. Multiply by what is inside. This is dy dx. And here is just 1. If I just want to have dy dx, at the end I'm gonna have minus 1 over sine of y, right? And if I look over here, this is exactly what we want, right? At the end, sine of y is that expression, so we're gonna have minus 1 over 1 minus x squared. And that's how you have it. So the derivative of r cosine of x, it's gonna be this expression over here. If I compare, right, if I try to establish a comparison between the derivative of r cosine and arcsine, what I notice is that the difference, right, is only the minus here. But at the end, it's the same expression, okay? Now, once that we have it, let's go to the last one. Derivative of arctan. Okay. Let me see. Of arctan of x. Again, I'm gonna say y is arctan of x. If I apply tangent to the both sides, right, I'm gonna have tangent of y is equals to x. Perfect. So if I want to know what that expression is telling me, what I should do is just a triangle, okay? And say, okay, this is y. This is y. Perfect. I know that tangent is opposite over adjacent, right? Over adjacent. So I have here x and here I have 1. So this expression is gonna be, let me do it like this, 1 plus x squared, right? Good. If I try to derive this expression, this expression, this one, I'm just gonna delete this, okay? What I'm gonna have is tangent second square of y dy dx 1, right? Dy dx is equal to 1 secant square of y. But I know, right, at the end, I know that secant of y, is 1 over cosine of y. So what I should do over here, right, is that I'm gonna have here cosine square of y, right? I mean, sorry. So what I'm gonna have over here, right, is 1 over cosine square, right? And this is gonna be a cosine square of y, right? Sorry. Cosine square of y, right? Good. Okay. And what is cosine square over here? As you can see, cosine square over here, right? It's gonna be this expression. Let me do it over here, okay? So I'm just gonna say that from here I went over here, okay? So this expression is gonna be x, right? I mean, it's gonna be like this. It's gonna be 1 over 1 plus x squared to the square, right? And at the end, what we're gonna have is 1 over x squared plus 1. So this expression is equals to the same expression, the expression that we have over here. And this is how you solve all the three derivatives: arcsine, arccosine, and arctangent. Thank you very much, guys.